All right, let's have a look at this question. The graph shows 3 points P, Q, and R relative to the origin O. We're asked to what? Write as a column vector in the form x, y, the vector OP. Well, that's not difficult. The vector OP would be what? P is, give me the coordinates of P. Let me know. What are the coordinates of P? The coordinates are what? 4, -1. So the coordinates and the position vector, they are the same. The coordinate and the position vector is the same. So if the coordinate of P is 4, -1, the position vector is also what? 4, -1. The position vector is 4, -1. That's one way you can look at it. Another way you could look at it is that to get from O to P, I'd have to go what? How many units to the right? From O here to P. O is the origin. I have to go what? 1, 2, 3, 4 units to the right and what? 1 what? Down. If you move to the right, it is viewed as what? Positive. If you move to the left, it is viewed as what? Negative. If you move up, it's viewed as positive. If you move down, it is viewed as negative. So the position vector OP is what? 4 minus 1. One thing you can remember about position vector. For position vector, the coordinate and the what? And the position vector have the same numbers. So if the coordinate is 4, 1, the position, 4 minus 1, the position vector is also what? 4 minus 1. The position vector OP being 4 minus 1 means to move from O to P, you'd have to go what? 4 units to the what? Right and 1 unit down. Everybody clear with that?
Yes, sir.
Next, the vector QR. The vector QR. We can get this from inspection. The vector QR. We could get it by calculation, or we can simply get it from what? Inspection. QR. Alright. To move from Q to R, are you all listening? To move from Q to R, how much do you move right?
4.
You move what? 1, 2, 3. 3 right. Do you go up or down? How much up?
5.
1, 2, 3, 4, 5. QR is what? QR is what? 3, 5. QR being 3, 5 means to get from Q to R, you'd have to move what? 3 units what? Right and what? 5 units up. Next. Determine the magnitude of the vector QR. That's not hard either. Sorry. This is I. The magnitude of the vector QR. Can I show you the problem here? Is if you didn't get this, is because you never know. It's because you did not what? No. But you should what? After I do it one time, you should never get it wrong again. It is what? The square root of what? 3 square plus 5 square. 3 here, 5 here. This is the square root of 9 plus what? 25. This is the square root of what? 30 how much?
4.
4. Use the calculator. What is the square root of 34? Somebody tell me. What's the square root of 34? Give me three significant figures. This is 5.83 units. The magnitude of QR is 5.83 units. It says on the what graph provided, alright, this wouldn't have been the graph provided. In the actual exam, They would have a graph somewhere on the what in the exam, and they will tell you what page. In the booklet, you'll find the graph, and you'll have to draw it on that graph. It says what? On the graph provided, draw the vector OS. OX is what? Is 7, 4. What type of vector is OS? Help me. OS is the vector 7, 4. I'm asking, what type of vector is OS? Start with P. Lord, prepare me to the sanctuary. It is a position vector. It is a position vector. What is a position vector? A position vector is a vector that is tied to the origin. So OP is a position vector. QR is what you call a displacement vector. Kind of O in it. Then what? OS would be a what? A position vector. A position vector is a vector that is what? Tied to the origin. Now, OS is the position vector of what? S. The position vector and the coordinate of what? S have the what? Same what? Value. It means that the coordinate of S is what? 7, 4. This is 7 out here, so 1, 2, 3, 4. This is what? 7, 4. This is what? S. And this, that would be the position vector what? OS. Are you ready? What did they ask us to do? Are you listening? Are you listening? On the graph provided, draw the vector what? OS. I don't find that people listen. I said the position vector and the coordinates of the what? This is the position vector of what? S. The position vector is 7, 4. It means therefore that the coordinate of S, it means therefore that S would be the point 7, 4. The position vector of S and the coordinate of S have the same values. So all I have to do is find S. S is what? 7 vertical, 4 horizontal, that is S. But the man say you must draw the position vector. A position vector is a line that is what? Is a vector that is what? Tied to the origin. From the origin to S, with an arrow pointing towards S, is the position vector OS. Please listen. Show. Are you listening? Show that what? Read it. Show that PQRS is a parallelogram. How do you show that a shape is a parallelogram? Alright, what makes a parallelogram a parallelogram? What is a parallelogram? What is a parallelogram? Can anybody say to me that we can understand? What is a parallelogram? You see, that's what people do when they don't know what they're talking about. When people don't know what they're talking about, they mumble. Like the people that move up on the choir, who in the back, and instead of them, I say nothing. Please listen. Are you listening? Are you listening? A parallelogram is a quadrilateral in which opposite sides are equal and parallel. A quadrilateral is a parallelogram in which opposite sides are what? Equal and parallel. Opposite sides, it means that what? QR and what? PS would be what? Equal and what? Parallel. Alright? 1. So we're asked to show that a shape is a parallelogram, you must show that at least one pair of opposite sides are equal and parallel. Because you see, if one pair of opposite sides are equal and parallel, the other pair of opposite sides must also be what? Equal and parallel. To show, and this is something we have done already, especially with the day school, I didn't do it with evening school. To show that a shape is a parallelogram, you must show that one pair, at least one pair of what? Opposite sides are equal and what? Parallel. Alright? We have what? We have QR, don't it? Help me now? See there, we have it. What we need to do now is to find the vector what? Help me now, please. PS. Triple I. Give me PS. Give me PS, please. I'm guessing that we can do it by what? By inspection or by what? Calculation. What is PS? I said, Jesus help me, you know. PS.
3, 4. 3, 4.
Are you all seeing PS? This is what? 1, 2, 3.
3, 4, sir.
3,
4.
then this is what? 1, 2, 3. Sorry? 1, 2, 3, 4, 5. It's what? What is QR? What is QR? What is QR? QR is 3, 5. So can I therefore say that PS and QR are equal vectors? Can I say that? They are equal vectors. If they are equal vectors, it means what? 1. The line PS and QR are what? Are parallel. Ladies and gentlemen, if two vectors are equal, the two vectors have the same magnitude and the same what? Direction. If two vectors are what? Equal, the two vectors have the same what? Magnitude and the same what? Direction. Watch me. So since these two vectors are equal, it means therefore that the line representing the what? Two vectors are also equal in what? Length. Equal in length. They have the same what? Magnitude. Now, if two vectors are what? Equal, they have the same magnitude and the same what? They have the same, Jesus, the same magnitude and the same what? Direction. The same direction. If two lines have the same direction, the two lines are what? It started P. So, it means that what? PR, PS, and QR are equal in length. Therefore, P, Q, R, and S, P, Q, R, S is a parallelogram. Remember to tell me why is it up? Why? By saying that these two lines are parallel and they have the same what length, why does that conclude that the shape is a parallelogram? Why can I conclude based on that the shape is a parallelogram? Very good. As I said, to show that a shape is what? A parallelogram, you must show that these what? At least one pair of opposite sides are what? Equal and what? Parallel. Because if one pair of opposite sides are equal and parallel, the other pair must be what? Equal and parallel. And if you have a quadrilateral in which opposite sides are equal and parallel, that quadrilateral is a parallelogram. Next. Next. It done? That's it.